So, dear students, I welcome you for the today's lecture related to the different terminologies associated with the pressure. So, it is the pressure which is nothing but the one of the most important parameters that is used for designing purpose. And in various books or various when you come across the term pressure that is talked in terms of different terminologies, that can be your normal operating pressure, working pressure, then maximum operating pressure, then maximum allowable working pressure. uh, so all these then design pressure, all these different terminologies that will be associated with the term pressure. Now, what are the distinctions or what are the basic considerations that is generally preferred? It is generally preferred related to this pressure term. It is the normal operating pressure. That is the pressure at which you expect the process to usually be operated. That is the general or normal operating pressure. It is defined by the kinetics and the thermodynamic considerations. Kinetics define you the pressure requirement. सो इस प्रेशर पे ऑपरेट करने के बाद में मेरे को ये प्रोडक्ट मिलेगा एंड दैट इज ऑफ दिस कन्वर्शन. So this pressure, normal operating pressure, that is the process which is usually operated or is supposed to be operated. The pressure which is required for the process at which the vessels are normally operated. That is also called as the working pressure also. Sometimes that is also called as working pressure. That is the maximum pressure at the top of the vessel, and that is considered or taken into consideration the top of the vessel under normal operating conditions. So operating conditions, working conditions, that is more or one or the same thing. Maximum operating pressure, that is this is the highest pressure expected including certain upset conditions. That is, if there are certain abnormalities or the upsets or the pressure fluctuations while operating the plant. So these are the maximum surge in the top vessel pressure or maximum surge in the working pressure, such as when the situations arises, that is at the time of startups, shutdown, or certain emergency cases or certain malfunctioning of certain instrument. At that time these pressures they can be going to its maximum level, and the maximum operating pressure, and after that the pressure should be released so that your safety valves, pressure safety valves or pressure regulation valves, or you can see the rupture disc, all these are set at this maximum operating pressure. So this is the maximum operating pressure at which you are expecting that the pressure fluctuations can be there and they can reach to the maximum value, highest pressure expected including certain upset conditions. That is your maximum operating pressure. Then next is maximum allowable working pressure. So the internal pressure at which the weakest element of the vessel is loaded to the ultimate permissible point. That is the, it depends on the internal pressure at which the weakest element of the vessel, means at the curvatures or at the joints, that is your weakest element, or sometimes where the instruments they are provided or the nozzles they are provided, and for that time the welding that has been done, all these are considered to be the weakest elements of the vessels, and that is loaded with the ultimate permissible point, that is the ultimate permissible stress. when the vessel is assumed to be in corroded conditions under the effect of design designated temperature in case of normal operating position at the top, then under the effect of other loadings which are additives to the internal pressure. So these are the different conditions where the maximum allowable pressure, that is to be corroded conditions पे check कर सकते हैं. Then when the calculations are not made, the design pressure may be used as the maximum allowable working pressure. Again, that depends on the factor of safety. When the calculations are not made for the maximum allowable working pressure, the design pressure may be considered as the maximum allowable pressure. We will see the term design pressure also. The common practice followed by many users and manufacturers of the pressure vessel is to limit the maximum allowable working pressure by the head or shell, not by small elements of the flanges, openings, pipes, and etc. So generally, your flanges, openings, and pipes, they are of the higher diameter. Preferably, they are of a higher diameters, higher thicknesses, so that it can accommodate these pressure fluctuations. However, the bigger size, that is your head or the shell, which is involving the more cost, and there the cost cutting, keeping in the mind related to the cost cutting, so people try to minimize the thicknesses of this head and shell, and so they become more critical problems. Then the maximum allowable pressure for flanges, maximum allowable pressure for the pipes, that is also to be taken into consideration. The term maximum allowable pressure, that is the new and the old, is used very often. It means the pressure at which the weakest element of the vessel is loaded to the ultimate permissible point. When the vessel is not corroded and is corroded, that is after old, after certain service life. So नया कितना है, and after certain service life what is expected, after certain number of years, there will be certain corrosion, certain deterioration of that metal that will be there, and what can be its strength after that period. So that is to be taken into account, and the other conditions also need to be taken into consideration. Then the design pressure, which is the most important terminology. The design pressure and the corresponding design temperature are the conditions of designing load, and its value is not less than the operating working pressure. That is, this design pressure must be more than maximum operating or maximum working pressure. Design pressure must be more than the maximum operating or maximum working pressure. So generally the maximum operating pressure, that is given in our numericals, and it can be multiplied by a factor of 1.1 or 1.2 or even 1.5 or 2 or 3 or 5, that depends on the safety requirements of the प्रोसेस की कौन से टाइप की है उसके ऊपर मेरे को डिसाइड करने का है उसकी सेफ्टी. If it is simply the water which if you are handling, then there is not so big issues. But if you are using the very high pressure water, then there can be issues. Then if you are using the corrosive chemicals, then there can be the issues. Even if vapors are corrosive or vapors are flammable, then there can be the issues. So with this complexity, now if you will say nuclear power plants which are designed to a maximum level of the safety. So at that time, I'm going to change this factor of safety, say by 1.1 or 1.2, which is generally used, can be increased to 2, 3 or 5 depending on the process requirement. So generally in case of our numericals or any process is defined, that is the maximum operating pressure that is defined. Then from that operating pressure, one has to calculate the design pressure by multiplying by the factor of safety. That is going to give you the design pressure. So maximum operating pressure plus a safety margin that will be there. The margin is typically 110% of the maximum operating pressure or 25 psig, which is the greater one. Then usually specify the pressure at the top of the vessel where the relief wall is located. A pressure vessel shall be designed for at least the most severe conditions of coincident pressure and the temperature expected in the normal operation. Then the calculated pressure. This is the pressure which is used to determine the thickness at the corresponding design temperature, including the liquid static pressure. So design pressure and the calculated pressure is used to determine the thickness at the corresponding design temperature or design pressure. Means I am considering the static pressure also. Here I am considering the gauge pressure, and in addition to the gauge pressure, the static pressure that has to also to be taken into consideration. Similarly, the temperature terms that is also there, that is the maximum, that is the highest mean metal temperature expected in operating, including the transient condition plus a certain margin of say 50 degrees Fahrenheit. Then the minimum temperature, that is the lowest mean metal temperature. It is related to the metal temperature, lowest mean metal temperature expected in the operation, including the transient condition. Transient condition means at the time of shutdown or certain winter seasons in some cold countries. All these are taken into considerations. Certain upsets, then if the reactions can be auto refrigeration reactions also, then climate conditions are to be taken into account. Then other unexpected situations also to be taken into account. A margin which is typically minus 25 degrees Fahrenheit. Then MDMT, that is the minimum design metal temperature, and is important as metal can become the brittle at low temperatures. So this is given the consideration where the climate changes are very low. So minimum design metal temperature has to be given thought in cold countries. Then the designer should allow for possible failure of upstream equipments. Then the design temperature T, the enacted temperature of the metallic components under the normal operating condition. Then design pressure and design temperature, both are the design load conditions, that is the allowable stresses.